We shall commence this module by discussing environmental resources. This module would be taking into account various methods for evaluating environmental resources. Environmental resources are extremely useful and immensely valuable for human beings. All useful goods and services are bought and sold in the markets. It is the market which assigns value to these goods through market equilibrium prices. Prices in turn reflect scarcity, allowing for efficient utilization of limited resources. This is possible for all goods that are traded in the market. However, a large variety of environmental goods are not traded in the markets. Many of them are environmental goods that have either use or non-use values, but not traded in the market. Because of the absence of markets for environmental goods, measuring demand is not straightforward. Economists have identified variety of tools to value these changes. Various methods of valuing environmental goods are discussed broadly in this module. These valuation techniques can generally be classified into observed methods and hypothetical methods. In the observed method, either the benefits or the damage from change in supply of environmental goods is measured. The benefit or damage is measured by observing the behavior of users in the usual markets of environmental goods or markets for related goods. In case hypothetical methods, markets are not available to evaluate consumers' willingness to pay. Economists have designed techniques for valuing non-market goods by creating hypothetical markets where economic agents are asked to state their preferences. In both the approaches, environment can enter as an input into production process. For example, health production function, or environment can act as a characteristic of the market-based good. As a result, in any environmental study, one has to first choose between revealed preferences and stated preferences method. Revealed preference methods use the data observed from the real market and provide reliable estimates of environmental values. However, these methods cannot be used to estimate non-use values. Therefore, contingent valuation method is employed which can evaluate both use value and non-use value. After studying this module, you shall be able to understand the need to value environmental goods, know about basic environmental valuation techniques, comprehend about ways of assessing environmental goods, understand methods of creating hypothetical markets, understanding the model used for valuation technique, and comprehend the right choice of technique while valuing environmental goods. Let us now begin our discussion on the valuation methods. Environmental goods, though valuable and useful for economic agents living in society, do not have well-defined markets. This non-existence of market for these goods creates problem in measuring demand of environmental goods. There are two basic approaches to measure demand for environmental goods. First is revealed preference and second is stated preference. Let us first discuss the revealed preference approach. In revealed preference, real choice is observed in the prevailing markets and thus the trade-off between money and the environmental goods is inferred or derived. For example, it is possible that if there are two identical communities but with only one difference, that one of them has higher prices of houses, these high house prices are associated with clean air, while in the other community the prices are lower, reflecting low quality of air or dirty air. The stated preference approach is of stated preference. This method involves asking people about the trade-off between money and environmental goods if they were given a chance to do this. There are various methods used in order to take this account of trade-off. Opinion polls and surveys are used to obtain this information. The experience exhibits that this approach is controversial as this approach is not based on real choices. Therefore, there are no actual trade-offs or actual trade between money and environmental goods. Further, this theory is based on hypothetical choices, so the information provided may not be accurate. There exists a great deal of debate and controversies among economists to accept this method of valuing environment because choices are not real, they are hypothetical. Existence of experimental methods reflect the characteristics of both approaches. In experimental markets, people are given money and they are asked to make their choices as a result. In such cases, decisions are real. In revealed preference method, there are two approaches for measuring demand. First is hedonic production function approach and second is household production function approach. Hedonic approach. In hedonic approach, the aim is to observe how price of a usual or marketable good is determined. For example, price of a house varies with a closely related environmental good like air quality around the location of the house. The relationship between the house and the air quality around the house is then used to measure the value of the environmental good, that is air quality. In this method, price of a commodity is a function of characteristics it possesses. For example, land has different characteristics in terms of location, size, and environmental quality in its vicinity. Similarly, different jobs have different characteristics in terms of risk involved like on-job accidents, training and enhancement of skills, local environmental quality, etc. By observing changes in the price of marketable goods with respect to changes in characteristic of good, an economic agent pays a price or premium for a particular characteristic of the good. This creates the underlying notion or proposition for hedonic approach. Various environmental characteristics like air, water quality affect the price of the good like land or houses. Consider a good with single characteristics, for example, house with different levels of characteristics such as number of rooms or pollution levels. This involves determining the price of good in the market and deducing the consumer willingness to pay for changes in the characteristic. The first step is to identify a single homogeneous area such as a city. This can be considered as single market from the point of view of our good, that is house. Each house is characterized by a single variable Q, which is air quality level. The aim is to find P, that is how price of the house varies with the pollution levels, that is P as dependent on Q. In order to find P as dependent on Q, we need to consider both consumer side and producer side of the market. We assume that market is competitive, implying both producers and consumers. First, let us discuss the consumer side. Consider a consumer with utility function U and income M. The consumer buys only one house. The consumer spends his income on consumer good X with nominal price 1 and the environmental quality Q. Therefore, utility is given by U, which depends upon X and Q. Let lambda be the maximum amount of money consumer is ready to bid. U star is the desired utility. So, the objective is to maximize lambda such as U, which is a function of X and Q, is more than or equal to U star. This maximizing objective will subject to the budget constraint X plus lambda equal to M. Consumer chooses the maximum he can bid for the house, achieving maximum utility given the budget constraint. Finally, given the values of Q, M and U star, we determine how much money is available for the house. Lambda, which depends upon M, Q and U star, is called the bid function as it reflects the amount of money consumer is willing to bid for the house with characteristic Q level of air quality. If this exercise is repeated for another consumer with different income, then different set of bid functions are obtained. The consumer's problem is to obtain the level of air quality Q that maximizes his utility. The price line is given by P. So the optimal point for consumer is the point at which bid function is tangent to the price function P. After discussing the consumer side, let us now discuss the producer side. On this side of market, there are producers of the houses. Different producers have different costs. The producers specialize in different segments of housing. If we consider a producer with a given cost structure, assuming it follows constant returns to scale, therefore deriving the cost of producing one house characteristic Q. Suppose the producer faces input price W and unit cost given by C, which is a function of W and Q. If the producer offers a price of alpha, then profits per house are given by pi is equal to alpha minus C. Given the level of characteristic Q, the level of profit function can be obtained as alpha as a function of W, Q and pi. This is referred to as offer function. The offer curve indicates the price at which the producer will offer the house in order to attain a particular level of profit given the input price W and level of air quality Q. If the producer wants to sell a house, this offer curve would intersect the price line at a point. Finally, the above two offer curves of both consumers and producers must have one common point of intersection for attaining equilibrium. The tangency point would imply slope of the offer curve for consumers is equal to bid function of producers, which is eventually equal to the slope of price function P, which indicates how much price goes up when air quality Q changes by 1 unit. As a result, the basic idea in this method is to observe hedonic price function in the market. Later, measure the slope, then using the slope as price of characteristic, we measure demand for the characteristic. The second production function approach is household production approach. The household production approach starts with the notion that environmental goods do not have market of their own. The consumers therefore combine private goods with environmental goods to produce another good which is of greater quality. A national park could be combined with expenditure to visit the park in order to generate a park visit which is highly valued by people in the society. Therefore, the visit to national park must be worth at least the travel expenditure. By observing expenditure on the complementary good private in nature, we derive the lower bound on the value of environmental good. One of the version of household production approach is household health production function. It can be used to estimate the value households place on benefits of reduced morbidity and mortality due to reduction in air and water pollution. When the health changes occur as a result of environmental factors, the change in the productive activity can be measured and valued. Another version of household production function is travel cost method. It is basically used to value recreational benefits like parks and natural areas. The underlying assumption or notion is that there is weak complementarity between the demand of environmental good and private good like travel. In this method, utility of an individual depends on total time spent at the park or the natural area, the quality of the location and the quality of composite private good other than travel with the duration of visit as fixed. The time spent on the location is represented by number of visits. The individual maximizes the utility function U subject to the budget constraint. Maximizing of utility subject to budget constraint would yield individual's demand function R, where R is a function of PR, Px, M and Q. Px is the price of the private good, where M is the exogenous income and Q is the environmental quality at the site. The travel cost method can be used to estimate demand for recreational services offered by environmental natural resource. Next, we shall discuss the stated preferences. In the regime of stated preferences, most prominent approach is termed as contingent valuation method. This method depends on direct revelation of demand from consumers. It means the value given to the environmental good contingent on there being a market. That is, if there were a market, then how much amount would be paid for the environmental good? It is a kind of constructed market in which a researcher will generate or construct a market given a situation when no market exists. Contingent valuation method is a survey-based tool. The survey instrument seeks to create a hypothetical market, and response to this market allows the researcher to estimate respondents' values associated with environmental good. These constructed markets can be real or hypothetical. Many times, laboratory experiments are also widely used to generate the information on how people can trade money for environmental goods. Laboratory experiments are useful for extracting data that are otherwise nowhere available. Such experiments may involve real decisions involving monetary transactions. This includes example of creating market for buying and selling of permits for duck hunting. These experiments are very costly to hold or construct and involve non-random selection of samples like students from related fields. Therefore, it is difficult to journalize the results. Another type of constructed market is official referendum. Under such markets, idea is to provide some environmental good using a tax on residents of a community. Here, the proposal is put forward in front of the voters, which leads to real choice situation. Its application is limited to environmental goods offered in the community through referenda. Further, another approach emerged which is known as benefits transfer. This is a poor man's approach to valuation of benefits. This is used when researcher does not have resources to conduct any experiment or a study. Then literature survey can help find similar analysis and can transfer them to their application. Let us briefly conclude what we have gathered in this module so far. Environmental goods, being so useful and crucial for human beings, do not have markets. As a result, it becomes difficult to ascertain value of such goods. Various methods have been formulated to assess value of environmental goods. This module provides a short account of various methods of environmental valuation. There are both observed, also known as revealed preferences, and hypothetical method, also called as stated preferences, of evaluating environmental goods. In revealed preference approach, environment is taken as an input to production process. Both the methods, hedonic and household production function, are based on actual choices people make while making trade-offs between market goods and environmental goods. This enables us to derive the demand curve for environmental goods. While in stated preference method of valuation, an individual's willingness to pay for a good is evaluated by using a set of questions regarding preferences and decisions. Other methods are surveys like travel cost method of asking people who visit parks. The most prominent approach under this method is contingent valuation method, also known as CVM, where individual is asked to hypothetically imagine a situation and speculate his behavior in this situation. All the methods of valuation of environmental goods mentioned in this module will be discussed in detail in the next module. Now we will summarize what we have discussed in this module. Various methods of environmental valuation techniques can be broadly classified as revealed preference and stated preference. Revealed preference methods take environment as input in production process, while stated preference methods evaluate willingness to pay on the basis of questions regarding individuals' preferences and decisions. Revealed preference method can have two types of approaches: hedonic production function and household production function approach. Household production function has various versions like household health production function and travel cost method. Stated preference method, which is based on direct revelation of demand, has most commonly used method of contingent valuation method or CVM. Contingent valuation method is based on constructed or hypothetical markets. Various laboratory experiments are also part of this method.